Morning, everyone. Welcome to the second day of CitA Tech Live. My name is Eamon Shields. I'm from SDAI, and I was very delighted to be asked to chair this morning's event. So I understand yesterday went very well, so hopefully we're in for a similar day today. I'm just going to give you a brief outline of what's going to happen today. Firstly, I suppose just from my side, as I say, I'm from SEAI. I'm the commercial manager for the commercial retrofit program. And this is a new program which has only started off this year. My previous experience, I was a M&E consultant for 20 years. So I'm very fresh to SEAI at the moment. Just to give you a sense of what SEAI do, I suppose, if you're not that familiar. So our main goals really are to get Ireland to move towards a low carbon energy future. So we need to use less energy and clean energy, and energy should be environmentally sustainable, secure and affordable. And we develop new solutions to meet our energy needs. So I suppose, just to give you a kind of a high level view, and again, being aware of the audience I'm speaking to here, I think it's great to see these kind of events going on, and we're really positive about this. And this is why we're eager to get involved in these kind of events, is because at this stage, and with the crisis at the point that it is, we need to use every available tool at our disposal to meet the challenge ahead. So digitalization is a huge part of that. And I'm not going to get into the whole, global aspect of things. I think people, if you're on this call today, you're aware of what needs to happen. And going forward, going forward within the industry, there are massive challenges ahead. And the reality is that everyone is going to have to get on board in terms of embodied carbon calculations, in terms of the operational carbon of a building and the end of life aspects of that. And I suppose, just to be frank about the whole thing of this is no longer a nice to have or something that's going to be interesting for your clients to have. You can see in the large scale commercial sector, the fact is that all these elements are now requirements. The large scale commercial sector is an indication of what the whole sector needs to do going forward, because they have the expertise to know what's coming down the line. And regulations in terms of the new EPBD that's being drafted in Europe at the moment is going to put requirements in terms of calculations of embodied carbon of new buildings in by 2027. And like the operational calculations for new buildings and existing buildings and the controls of those buildings are all going to be brought in under regulatory measures over the next few years. So digitalization is no longer a nice to have. It's going to be a requirement for all people. So I just think it's really positive that this event and the people attending it are taking an action approach to these things as opposed to trying to work against it. So so as I say, very excited to be involved, and going forward, SEAI wants to be involved in. If anyone's out there and has any potential ideas or anything else that they think is going to help with the challenge ahead, we're really open to speaking to you. So thanks very much. And without further ado, I will move down to the speakers of today, who you're really here to see. So just to give you a brief outline. So Zulkefly Bakar is the BIM coordinator in MCA Architects, and he's going to be talking about machine learning to support BIM-based material analysis for embodied carbon assessment. So again, this is very pertinent to what I was speaking about. There's a whole EU working group going forward who are coming up with how all these materials are going to be assessed so that you can calculate the embodied carbon of a new building. So that's very pertinent there. Susan Price is the research consultant for IES, and they're carrying out some really interesting work and achieving Limerick's 2050 vision, how digital twin technology is supporting the drive towards net zero cities. So again, that's the operational carbon side of things, which again is very interesting. There's a video recording from Deborah Smyth, Managing Director of Temp Housing Ireland, And that's about how using DFMA to deliver net zero carbon. So again, all very pertinent. And then finally, Dwyer, AEC Division Manager for Procad, is going to talk about managing the hybrid working model with Autodesk AEC and Naviate Tools. So that's the lineup for today. So I'm going to leave you now for a moment. We'll be back for questions at the end, and I think we're going to leave questions until the end. So Zulkefly, if you want to start off, and I'll stop sharing now. Thank you. I think you're on mute there, Zulkefly, if you want to.
Sorry. Yeah, should I share my screen now?
Yeah, please.
Yeah, sorry.
Yeah, that looks good.
Sorry, having a technical difficulties to hide all the tabs in there. But anyway, hi everyone. First of all, thank you to Dr. Alan and all the people at CitA for providing me this excellent opportunity, and also I find it's excellent platform for all the AEC professionals to connect and share or showcase their real world ideas and projects. So I actually recognize this platform as importance, at least for me, to support my skills and future knowledge development. So for today, about myself, a bit about myself. So my name is Zulkefly. I'm a BIM coordinator. Currently work at MCA Architects. I have a architecture background and about 17 years in the industry. So I'm not actually a data scientist or energy consultant expert by any means. So apologies for any shortcomings on my presentation today, but I'll be taking I'll be talking about my final project that I created during my study at NCI last year. So the title of my project is Machine Learning to Support BIM-based Material Analysis for Embodied Carbon Assessment. So this project is actually represent my reflection on what I have learned about the data science, AI, and machine learning using the embedded carbon as a use case study. So next one. So this is actually my third presentation at the CitA event since last year. So I consider this study is a continuation of similar topics of the importance of using an open technology and created use cases and data government in the AEC industry. So if you want to check out, there's a link sent in the presentation. So next one. So my presentation today is focused on actually assessing embedded carbon using machine learning technique. But I start the session with reviewing BIM-based embedded carbon assessment. And then secondly, I want to discuss about the method, technology, and the system that have been applied to construct this study. So thirdly, briefly guide you about the implementation of the machine learning process, the calculation, and briefly showcasing the front-end application that I developed for this project. So finally close out this presentation today with a discussion of my future study, hopefully. So before going into the actual project itself, so I just want to clarify the scope of study is only inclusive calculation within a cradle to gate boundary between A1 to A3 life cycle model. So this factor only cover extraction, processing, transportation, and manufacture of materials and products up to the point where they leave the factory gate to be taken to site. And this information I find can be found on the easily find available on the ICE database, or you can search in the published Environmental Product Declaration, or EPD, which is standardized the way of providing data about environmental impacts by the producer or the product maker. So the learning objective of this study is to learn how to generate data for the machine learning assessment, use the machine learning techniques and model to support BIM-based material analysis. So hopefully this exploration help users to understand and assess embodied carbon influence in their building material selection or design. So since this is fairly new topic to me, so it is necessary for me to discuss about general overview of the embodied carbon, discuss what it is, recognize the key factor contributing to the embodied carbon calculation. And the idea here is to observe the impact of this material to the global warming, or usually measure using a GWP, global warming potential unit. So the embodied carbon means all the CO2 emitted in producing materials. It estimated for the energy used to extract and transport raw materials, as well as emission for manufacturing processes. Embodied carbon usually expressed in kilogram per product or material produced. So it can be measured by using this simple equation of embodied carbon equal to quantity of material times the carbon factor. So in BIM material analysis, this calculation process can be easily implemented in any BIM tools, I assume. So for example, by using Revit and Dynamo, for example, the EPD can be pulled to the BIM objects, and the embodied carbon information that's stored in the database can be applied to the object materials for the material takeoff, and then visualize back in the model by using a filters. There is improvement of how we can visualize the embodied carbon in the BIM model. But however, this assessment is typically carried out late in the design stage, or when you have a model constructed, when the cost is high and the changes is actually difficult to iterate. So does this study develop a method using machine learning algorithms for assessing buildings environmental performance through material selection in the very early design stages? So perhaps before we have the actual physical model started. So this can work, the machine learning model can work as indicator to support any design decision. So this can actually minimize environmental impact, reduce costs, improve design and construction process, and also giving a designers the ability to specify material selection. So what is actually machine learning? The simple description about this, Tom Michel described machine learning is the study of algorithm that can improve performance, which is specifies P at some task T and with experience E. So a well-defined learning task is given by P, T, and E. So for my study, this can be described as I want to identify a material performance, and then forecast the environmental impact, and then as experience, embodied carbon assessment can be used for material selection. So the steps used for sequence machine learning process conducted during this study is a typical machine learning process include data collection, data processing, modeling, which is training, and visualization. So this is I list out or briefly describe the system or architecture proposed for this study. There are a number of programs used in this project development, both on the back and the front end. The main code is calculation were developed in the Jupyter notebook. This console-based text-only application provides extensive libraries and is based on the open technology and free to use. But it's actually difficult to integrate with other platforms. So this is a challenge for this study. So this is the more exciting parts, actually, the actual machine learning process. As highlighted previously, data is a key for any evaluation, and to obtain real data set that can match the study objective is a bit challenging for me. So in this process, I come up with a game plan to modify and generate new features from a baseline data set. New features were added is material properties using blob libraries in Jupyter Notebook. This is to ensure data is fairly distributed and aligned with the other features. So in this study, I included three new features, which include the floor types, floor thickness, and the GWP factor, which can be measured against the other features in the baseline database. So once we have the base data set, then the data evaluation can be carried out in the machine learning. So this process gives much better understanding how the data set is structured, understand the problem, and the best fit algorithm that can be used for this assessment. I'm using the Seaborn library for this to help me to identify the correlation factor between each features of the data sets, for example, and also to understand the classification problem that lies in the material assessment. In this case, I choose a floor type and see how it sits and distribute against and coordinate between the other features in the data set. So once data is structured, we can now use this data point and train it using machine learning algorithm. So for this example, I'm using K nearest neighbors, or usually classified as a KNN. KNN is a supervised machine learning algorithm that classifies a sample based on a category of KNN where K is integer. Usually, I split the data into a train and test set. This test will provide the benchmark used to evaluate the model. I then apply the algorithm and check the model accuracy and make sure it can make a correct prediction when the new data point is captured. So I also run an error test to tune the machine learning model and see how the K factor affect the classification or prediction results. As a small value of K usually means that noise will have a higher influence to the result, which if you have a larger value, it makes the machine learning work harder for the calculation. So to visualize what is actually KNN and this machine learning model, I construct a simple test prediction. So this is actually the best to test if the machine learning model work properly, which is usually called as a prediction method. My goal is to predict and classify what type of floor to choose, or by given the floor area and the embodied carbon factor. In this case, when I enter a new information as new data, so the model present a result as a type O and highlighted the nearest neighbors in the data sets, which is can be used as prediction for the machine learning model. So once the trained model is satisfied, and then it can be deployed to the World Wide Web. So I'm using Azure Machine Learning Studio. So this allows me to actually push the machine learning model into the web application that can use to aid visualization tool for this project. So the outcome for my study is really to provide like a simple dashboard, front-end dashboard that visualize analytics of embodied carbon database and can become a resource or library to the user. It also allows user to connect a BIM model and visualize BIM data, particularly related to the embodied carbon properties. And more importantly, this application enable forecasting building performance target and produce embodied carbon assessment report communication and interaction with the users. So various information about the carbon factor predictors analytics can be actually searching on this application. So as a conclusion, I believe this project has enabled a method that can be used to forecast embodied carbon in the early design process. I also identify a number of research gaps that can be filled with a more detailed study. I find that there is an opportunity for the machine learning model to push back to BIM authoring tools and act as generative design input and also I find there's an opportunity to extend the study beyond building life cycle and connect with the zero energy assessment. So I think that's about my presentation today. Thank you for your participation.
That's great. Thanks very much. It was really interesting. And I suppose it really falls into exactly what we were talking about in the intro. This is the kind of work that has to be done so that, and this, as I say, in the EU, they're currently working on how they're going to certify products and the rules to get certified and how you calculate that carbon. So that's really pertinent. Thanks very much for that, Susan. I think you're up next. Thank you.
Yeah, thank you. I'll share my presentation. So, hi everybody. Thank you for the opportunity to be here for these 3 days in attendance and also to speak today. My name is Susan and I'm a research consultant in IES, which is Integrated Environmental Solutions. And at IES, we develop digital twin technology, ultimately aiding in the decarbonisation of the built environment, so both existing buildings and planned future construction. And today I'm going to be sharing some of the work that we've been doing recently towards achieving Limerick's 2050 vision. So looking at how digital twin technology is supporting the drive towards net zero cities. So when we say a digital twin in IES, we really mean a physics-based virtual model of a building that behaves in the same way as the real building. And typically these are detailed single building models that are created with a lot of data behind them. And that might be what you're used to seeing when you hear of a digital twin. What we're also working on in IES is looking at large scale digital twins. So these are models of hundreds or thousands of buildings in a city or a district and trying to create a model that is as representative as possible of that building stock. And the aim is to create an energy profile of the city so that we can use that model then to test the impact of different plans and policies, either at building or at city level, to see what kind of an impact they would have on the energy consumption and the carbon emissions of the city. And what we've been doing is creating this model for Limerick city centre, which you can see here is about 1,500 buildings. And we've created it as part of our Positive City Exchange project. So we've been working with Limerick City and County Council to define the area that they were interested in looking at. And each of these buildings has its own model in this. So they've all been assigned construction types, U values, HVAC information, and end uses, and they can be simulated with the virtual environment simulation engine, either individually or collectively. And because we didn't have detailed information about each of the buildings, we did have to use kind of national databases. So for example, at this scale, we're looking at things like the SCAI and BER ratings or CSO data. And then where we were missing information from the city, we did some detailed digital twins, so carrying out site surveys and using meter data. So we have a few calibrated models of buildings that are kind of representative of the wider building stock. So for example, a lot of Limerick has kind of Georgian buildings. So we were selecting buildings that we could then kind of scale out, and that would fill in kind of any missing parameters that we needed. But the idea was to create this baseline model of the city and then use that as best we could to create a decarbonisation roadmap out to 2050. And This is the roadmap that we have created. And it's a difficult task to say to somebody, how do you want to decarbonize your city? Exactly what do you want to do? So the approach that we took was we took national plans, policies, and targets that we could find. So for example, the Climate Action Plan, and we've applied them to the energy model to see where Limerick would be in 2050 if they implemented all of the plans and if they met all of the targets between now and that 2050 milestone. And this is what we came up with. So I'll be going through the roadmap in detail, but we have the model itself will be on top, and then you have the roadmap here on the bottom from 2020 out to 2050, showing you the emissions in kilotons of CO2 per year. And the blue line here represents the building emissions. So those are the emissions associated with energy use for things like HVAC, lighting, appliances, equipment. We then have the orange line, which is transport. So transport isn't normally something that we would do in detail, but it is something that we wanted to do as part of the project. So we have done kind of a rough baseline estimate and then a future trajectory for transport emissions. And then the green line are the total emissions. So that's the combination of building and transport emissions. And you'll see that there are two green lines. So the top one is showing you how the emissions would be out to 2050 if the grid electricity remained as carbon intensive in 2050 as it is today. Whereas that's unlikely to happen. It is likely that our grid electricity will decarbonize. So that's where the lower green line comes in. That's our future predicted emission factors. So the further decarbonisation, that would be kind of external to the city if the grid were to decarbonise. And it's important to note at this point that it is only operational carbon that we're looking at the moment. So for buildings, we're really looking at the building in use rather than the embodied carbon. And for transport, we're looking at as the vehicle is being used. So for example, we haven't carried out a life cycle analysis of the batteries in electric vehicles. We have considered the charging of the batteries, but we haven't gone into a full life cycle analysis. But embedded carbon is something that we do want to add to this in future. But at this point, it is just operational carbon. So once we had that model, then we could use that, we could simulate each of the buildings to get these baseline building emissions and baseline energy consumption for the city. And you can see there, we have the distribution of energy use intensity across the city, which is on average about 350 kilowatt hours per meter squared currently. In terms of transport, because we couldn't simulate it in the model, we did kind of a rough external calculation. Really, Limerick just wanted as a starting point so that if they did have a detailed transport analysis carried out, they could just sub in the value that they got. So for this, we've used data from SEAI, so just the national figure of 11.2 megatons of CO2 being emitted by transport in Ireland. We've scaled that to Limerick by picking out the relevant modes of transport to that city centre hub, which is really private cars, light goods vehicles, buses and taxis, and then we've scaled that based on the population of the city. So it isn't a detailed transport analysis, but it is just a starting point for the city. And that was where we got this baseline. And from there, we could apply different measures based on what we could find out to 2050. So really, our major milestones are every 5 years. But some of the measures, as we found them, maybe had targets that weren't quite every 5 years. And that's actually where the first one is. So those smart meters that are expected to be installed in buildings by 2024. So we've assumed here in this model that all of the buildings will have a smart meter installed by 2024. That also there will be some kind of smart services provided to building owners, which is something that Limerick are already working on doing. So they're bringing out information packs for owners so that they understand how they can use their energy meter as much as they can to reduce their energy consumption, their bills, and by shifting their load and also ultimately reducing their CO2 emissions. So we've considered here that a building with an energy meter installed will have a 10% saving on their CO2 emissions. And that's based on some of our more detailed digital twins, combining those with energy meters. And it is kind of a best case scenario. So not every building will achieve this 10% saving, but it's kind of a best case for these smart meters. And then looking at our major milestones then in 2025, this is the point where we kind of chose to evaluate the main measures for both buildings and transport. So for transport, our targets are really coming from the Climate Action Plan and also from the Electric Vehicle Roadmap. So our main target is 60% of private cars to be electric by 2050. And that's 60% of the private cars that will be on the road in 2050. So we are considering that this kind of do nothing scenario will see an increase in emissions because there will be more cars on the road. The other target that we're considering is that they want to encourage more public and active transport journeys. So what we've considered in our analysis is the electrification of the different types of vehicles and also the supporting charging infrastructure and how that charging infrastructure will consume electricity and be responsible for an increase in emissions. And we're also looking at a change in transport modes. So people would switch from taking private cars or taxis and going to public transport, or going a step further and walking or cycling instead. For buildings, we're also looking at the climate action plan and that main target of 500,000 homes to be retrofitted to a B2 BER by 2030. And because we needed our targets to go out to 2050, we had to look to the International Energy Agency, who are saying that globally in developed countries, their cities will retrofit their homes at a rate of 2.5% per year out to 2050, which is actually in line with our target for 2030 already. We also have a target nationally for public sector buildings to be retrofitted to B2 BER by 2030. And then for commercial buildings, there is a target for a number of heat pumps rather than a number of retrofits. But we have, in consultation with Limerick, taken a best case scenario to be 100% of your commercial buildings retrofitted, just to see what is kind of the maximum potential for Limerick. And in terms of what we've considered to be a B2 BER retrofit, because we're applying at scale, we needed kind of a blanket solution that we could apply across all of the models so that we could run the simulations collectively rather than all 1,500 buildings individually. So the retrofit that we've applied is coming from kind of two sources that are kind of connected. There are these deep energy retrofit guides that Limerick have given out to their residents as part of the Positive City Exchange project, which is tailored to the typical buildings in Limerick. A lot of them are Georgian buildings. And also we have done work that has fed into this with our detailed digital twins. So testing all of the different retrofit measures and seeing which had the greatest impact and which combination would get a building to a B2 BER. So this is kind of the blanket retrofit that we've applied. So it's adding wall insulation, roof insulation, overall reducing the heat losses and the rate of infiltration. So in practice, that could be something like removing their open fireplaces in a lot of these older buildings. We're also looking at improving the glazing, carrying out a full LED lighting upgrade, and replacing old oil or gas boilers with an air source heat pump for both space heating and domestic hot water. So that might not be the ideal retrofit for a specific building, but it's what we've applied at scale across the model. And you can see here in 2025, the red buildings are the ones that we're saying will be retrofitted by then. And so we tried to group them in line with kind of the retrofit model of trying to achieve these economies of scale. So you can see some of them are scattered throughout, and those are the public buildings because they're harder to group. But we've combined kind of rows of commercial buildings and also housing estates. And that's the approach that we've taken when applying the retrofit. But to be in line with those targets, we would need to have a 50% public retrofit by 2025, 17% commercial retrofit, and a 12.5% residential retrofit. In terms of transport, we've considered that switching to active transport, and also to be in line with the target for private vehicles, there would need to be an 18% electric vehicle uptake for private cars and 20% for light goods vehicles. And then at this point overall, we're looking at an emissions reduction for the city between 20 and 24%, depending on the decarbonisation of the grid. And as we're looking to electrify the vehicle fleet, we do also need to consider the charging infrastructure. So we have modelled the existing chargers, the public chargers in Limerick, and we've simulated them based on typical charging patterns to come up with their electricity consumption and also the associated carbon emissions. And what we've done is at each point in the roadmap where you see chargers, we've added 10 additional chargers around the city, and we've considered the CO2 emissions as a result of the charging. And what we've also been able to use the model for when communicating with Limerick is pointing out potential areas that could benefit from a charger. So for example, car parks that don't have chargers already, or have dense housing areas, office buildings, schools. It's kind of helping them to distribute their charges more evenly around the city. The next kind of big thing that we're looking at is we're saying that if buildings are going to retrofit, so they're going to reduce their demand, within maybe 3 years of that in the model, we've considered that they will install some kind of renewable generation, typically solar PV panels. The analysis that we've done for Limerick is based on some of our detailed models. So you can see here 5 buildings with PV on the roof. So a PV provider went in and did a roof assessment to see typically in Limerick what is the availability of roof area, because the city is kind of made in these blocks and it's kind of similar between blocks. So we have the availability of the roof area, and then we've also used our calibrated digital twins to do a solar analysis looking at the shading and the orientation of the buildings. And we've simulated the generation of these PV panels. We've also been able to compare it to the building demand time series level for these buildings to see how much of it is actually being consumed by the building. So how much is generation matching with demand, and how much is there that could be shared with other buildings or exported to the grid. And we've used this analysis for these 5 buildings, and we've scaled it out across the city. So saying that if a building is retrofitted, within 3 years, they will install PV that matches this kind of analysis for renewable generation. And then you can see that by 2030, as we evaluate, we're seeing the next set of retrofits will have been complete, which are the orange buildings. And the average energy use intensity across the city will be down to about 237 kilowatt hours per metre squared, as all of the public buildings are retrofitted, a third of the commercial buildings, and a quarter of the residential buildings. And in terms of transport, then, we're saying that all buses and taxis will be electric, 40% of the light goods vehicles, and 34% of private cars. And we're looking at between a 30 and a 40% reduction in CO2 emissions for the city by 2030. So far, we've kind of been looking at building level measures, but we did also want to consider what could be done at city level. And we're really looking at 2 things here, which is introducing energy trading and looking at the impact of community projects. So energy trading is something that's being considered and being tested as part of the Positive City Exchange project. But we're basically saying that if these buildings are being retrofitted and installing solar PV, there may be potential for sharing the excess with neighbouring buildings that either haven't been retrofitted yet or maybe have a different demand pattern. So for example, if you have a home where it's empty during the day, but it has PV panels, it could share with a neighbouring office building, for example, that has a demand that matches better with the generation. We're also looking at or trying to consider the impact of community projects. So there's a lot of work going on in Limerick at the moment, even raising awareness about people's energy consumption and their carbon emissions. So we're also kind of trying to predict things that they could do in the future, like they're looking as well at community renewable projects, and also maybe having some green spaces, or really anything that will raise awareness among people. So it's something that is difficult to quantify, but we think when you're looking at city level, especially something like this where we're trying to involve the community, it is something that's important to consider. So we've estimated between energy trading and community projects about a 15% reduction in carbon emissions. And you can see that here added into the roadmap. And again, as we reach 2035, we're kind of hoping that we would have reached the next milestones for each of our targets. So here, half of commercial buildings will be retrofitted, over a third of residential buildings, 60% of light goods vehicles will be electric, and 40% of private cars. And at this point, we would have kind of halved the emissions of the city. And from 2035 then really out to 2050, it's just kind of the same measures trying to reach those targets by 2050. So you're seeing here by 2040, half of residential buildings would need to be retrofitted to reach that target in the Climate Action Plan, or at least Limerick's share of that target. And about 50% of private cars would need to be electric. Moving out to 2045 then, we're getting closer to the targets again, 85% commercial retrofit, 62% residential retrofit, 100% of light goods vehicles are electric, and 55% of private cars are electric. And then finally, by 2050, we really have looked at the best case scenario for Limerick. So if all of their buildings were retrofitted and they have this maximum renewable deployment on the buildings, and they've reached all electric buses and taxis, and then their private cars are 60% electric. they would achieve between a 61 and a 73% reduction in CO2 emissions, depending on the grid decarbonisation. And overall, at this stage, with our simulations, the buildings on average have an energy use intensity of about 140 kilowatt hours per metre squared. So this is what we have presented in Limerick. It's something that we have shown to the public as well. But really, we want to build more on it, and we do have some next steps planned. The first one is to enrich the model with information from the residents. So as I was saying, a lot of the buildings are based on SEAI or CSO data. But we have the model being shown publicly in Limerick. They have an innovation lab in there as part of Positive City Exchange and in collaboration with University in Limerick as well. And residents can go in, select their building and update the information. So if they know that they have insulation in the roof or what kind of lighting they have, and that will improve the accuracy of the model. We also hope that it will be something that we can update over time as plans change or as progress is made, so you can compare where you thought you would be with where you are now. And also we want to extend the analysis, of course, to include embodied carbon and life cycle emissions, because it is such a huge part of the entire carbon process, the decarbonisation process. So those are the next steps that we're looking at to improve the analysis from this kind of starting point that we have. But I hope that was of interest, and I'm very happy to be here, and I'm glad to have had the opportunity. But if anyone has any questions either today or in the future, feel free to contact me or anybody else in IS. We would be delighted to hear from you. So thank you very much.
That's great, Susan. Thanks very much. That was really interesting. I was delighted to see the CAP 21 document getting thrown up there as well. I think it kind of shows that people in the industry and people like yourselves and consultants are actually starting to take these documents and really see the importance of it. So it's great that I think if we're honest, I think the CAP 2019 document probably isn't as prevalent as the 21 is. So I think it's just great that everyone's kind of taken on and everyone's seeing it. It's not a document that's separate for the government. Everyone's taking it on and seeing what they need to do within that document and what their roles are. So that's brilliant. And I think the whole idea of the detailed calculations, so the real life usage of buildings that you're carrying out, I think is really important. Obviously the BERs and everything have their place, but in reality, we really need to be seeing, if we're not measuring it, we can't do anything about it. So I think that real life measurement is really important, and it allows you then to change back. So if things aren't happening the way you would have thought they would, you can go back, as opposed to just blindly carrying out the same operations in all buildings. So that was really good. Just amazing. Even just the graphics and everything else was really well represented. So thanks very much for that. And I think now there is a video going to be shown. So just wait one moment, please.
Good morning. It's a pleasure to present to you this morning at the CITA. And we're going to talk about using DFMA to deliver net zero carbon. The headlines: net zero is a hot topic globally, but what does net zero look like for dense apartment developments? Annual inflation for building and construction materials was 18.2% in April. For some materials, including metal and wood, the rate of inflation was much higher, at between 50% and 60%. The challenge: 300,000 homes needed. We need a rise in the quality of housing, look at fuel poverty, how it's escalating, the rise in energy costs, material costs, and the skills crisis in the building industry, and trying to move away from fossil fuels. So why design for manufacturing assembly? DFMA is different. We are producing homes in a factory, not in a field. Procurement approach needs to be different also. And we need to be familiar with the constraints of each MMC system. Using more than one solution may be needed for a particular site, and standardized modules can still achieve architectural significant homes. For tempo housing's approach, to the housing crisis using volumetric units with maximising finishing. Warmth and comfort, taking in fabric forests to minimise losses, optimal levels of insulation and standardisation of products. Focus on affordable housing, but also being able to adapt to other tenures and achieving net zero carbon. Building information modelling, BIM ready. So what is BIM? For us, it's a common language, accuracy and a common flow of information. This must be part of every asset management strategy and manufacturing DFMA ready. Modules as BIM objects. Our design, we've done the hard work for you. Looking at excellent thermal and acoustic insulation with rock wool and reducing overheating. Heat pump ready with Mitsubishi, class A1 cladding in a range of finishes, using renewable energy, also Lumiplug lighting and smoke detection. High performance doors and windows, Part M ready as standard. Looking from a 1-bedroom to family home, meeting the space standards, and also going up to 18 metres, which is about 5 stories. And how do we achieve net zero? We achieve this by using fabric forest, minimising energy loss to the home, eliminating coal bridging potential, ready for improved building regulation demands, optimising insulation elements of passive air tightness and U values. This is a key to performance is accurate construction. Occupancy energy use tested. When fabric is at its very best, renewables bring us to net zero. And any construction CO2 is offset. We achieved the gold standard in the Home Performance Index. This has been designed by the Irish Green Build Council, and it has created this to show the minimum compliance to regulations. So the typical building practices is around 70%. Some of the market leaders around 20%. We're in the 5% bracket, as we are some of the well-known innovators in the modular world and the new designs for MMC. Each home consumes about 1,400 kilowatts per annum, which is equivalent to 7% of an existing Irish house, up to €6,000 a year. By using renewables, we can bring that down to €280 a year by using PV panels and battery. Also, 100% of energy generated plus any export revenue can achieve zero bills on energy use, including plug-in. This is what we can achieve using our standardised units. Architecturally, significant schemes that will enhance the community. As you can see, using our 2 modules per apartment and having its own front door. 37 square metre homes with separate bedrooms. Our system is ideal for creating impactful schemes as part of a regeneration plan. This scheme was designed for Bristol City Council, and this went to public consultation where the community chose this design. This is our 37 square metre home, living room and kitchen. And this also is the 37 square metre home, showing the bedroom and shower room. Using our standardised units, we can achieve mixed-use schemes for houses, low-rise and medium-rise apartments. We've done this as part of the Innovate UK project and designed for manufacturing. All our homes can feature energy generation or plug into district network. And this is our Bluebell home scheme. We're really proud of this as we achieved the gold certification on the Home Performance Index. I'm really proud to be using renewables on affordable housing, reducing costs down to €280 per year. Thank you very much from Debbie Smyth from Tempo Housing, and John O'Brien, our technical lead, will be taking any questions that you might have on regarding these slides. Thank you.
Thanks, Deborah. I know you're not there, but thanks, John, if you could pass it on. So yeah, look, again, I think that's like feeding into the whole carbon side of things. Obviously, having factory built units or even elements of larger buildings, the level of accuracy, the level of quality, but also that minimizing of waste of materials is huge compared to sections of pipe and everything else landing on site. I think as we've all seen, and offcuts all over the place, and then massive skip loads of stuff that isn't used coming off the site at the end of the project. So look, it's just from a huge amount of areas. It's obviously a no-brainer, I think, as you said there, Alan. But I think like from the embodied carbon side of things, it's huge. I really think so. Okay, so we'll move on again. So Sean Dwyer from AEC Division Manager Procad is going to give us a presentation there. Thanks, Sean.
Good afternoon, everyone. How are you? I'll just start my slides here. 2 seconds. Can everyone see my screen?
Yeah,
perfect. So I'm just going to be focusing on kind of a workflows where we will utilize the tools that are within the AEC collection, and also tools that we have within the Symmetry own tech portfolio, where we can streamline kind of more leaner project delivery, and then kind of show how that is integrated into the EC3 sustainable engine that's available free to use on kind of model integration. So yeah, so kind of focus on introducing ourselves here. So what we're going to focus on is kind of just these kind of 4 key areas, just kind of showing the hybrid working model, how it can be used to reuse certain elements, and then kind of show a very brief overview of the Symmetry on tech, and then show then some basic features that we could spend days showing the features that are available, and then kind of how we transition then into the EC3 embodied carbon aspect of it. So just to kind of give a brief overview of myself, I'm division manager within Procad now that's moved into Symmetry. I've kind of specialized in the BIM 360 and all cloud related offerings from Autodesk, and we are elite specialized within the Autodesk network on all cloud related Forge developed utilities on the portfolio. So just to kind of make people aware that we are transitioning across to Symmetry, which is one of the largest resellers in the world. So we're kind of a mix of our Symmetry, which are Nordic, UK, and now Procad in July, and Microdesk, which are global. So all of this all encompassed into one. We have over 750 employees within just the AEC architectural side. We have 100 developers. There's over 400 consultants and over 200,000 users of Autodesk licenses. So kind of moving on now to the AEC collection tools. These are what people probably have within their own remit. So you see with the AEC collection, the docs element here is where you would have the ability to host your files in the cloud hosted environment. So if you were in a hybrid solution where you're working in the office and you're also working at home, you don't need to save your files down. What you do is you use the cloud as your hosted environment. And to do that within your collection, you just use the cloud model. There's no need for a Revit cloud work sharing solution. So you save your cloud model just utilizing your Docs license. So when you work away in your office, you save your cloud model. You have the ability then, even if you're traveling or if there's someone else on the project, they can start utilizing the issue management and the BCF and even have full control of it. So to use this, what they use the Docs app. So you're working away, just publishing a model, saving it as you would locally on your machine, and you place pins more or less as tasks for yourself, or you could have your lead director or so on relaying back information with photographic evidence or some sort of design changes and so on. They're assigned to you. You can comment on them accordingly. So you're kind of introducing a more collaborative internal workforce and so on, just so that there's no issues missed and everything is caught and tracked, and you have a log of issues that you need to attack. The benefit of having this within the Docs environment is having the ability to integrate that into your own Revit environment. So say if you have your own AEC collection at home, you have the issues plugin for Revit. So it's similar to BCF, but we're using the Docs platform as a way of tracking the pins. So if you can see here, there's the pin that was created on someone probably traveling in their own car, placing pins across a model. So they're assigning tasks and issues that maybe have been discussed with the client or some other of the design disciplines. And that's on the right-hand side as a task. So you can make that change, comment on it within the environment and close it out, which in turn will close it out in the Docs task issue environment. It can also be used as a way of viewing files out on the field, and you have the ability to pin and attach photographs, assign tasks, and so on. So this is solely just using the AEC collection tool that is the Autodesk Docs, one of the 20 plus solutions that are within the AEC collection. So now kind of we're moving on to, because we're part of this Symmetry brand, they have their own technology division, and we're just focusing on the AEC division on that. With that, they have Naviate, which is more AEC focused. There's Sevilla and there's CQ. CQ is more a licensing kind of management model where you can track users of your licensing, which is an expense. You can track to see that they're used by the right people, that they're being fully utilized, and decide then at key renewal dates whether they are being used. And either if someone has an AEC collection and they're only using it for opening CAD drawings, maybe it's worth looking at a different solution. So these are kind of tools that we built in-house to suit the industry. So these are within the Naviate. There's Naviate for Revit, where you have all these Naviate extensions that sit within the Revit environment. So one in particular would be Naviate Accelerate, which would have the ability to run room data sheets. It has the ability to host all of your families within a cloud environment. So you're not having to have certain individuals within the design department having their own custom families. These are families that are controlled in a kind of correct environment, and any version controls within this cloud hosted environment they're pushed out to the relevant users. That's one of the 100 plus features that are within the Naviate for Revit platform. You also have the ability for using it within the architectural industry. You can do daylight analysis as well within the Naviate platform. There's also Naviate for Civil 3D, where you can do project design, where you can do road design and so on using the Naviate for Civil 3D plugins. And what's also available now is the Naviate for Cloud, where you have Nexus, which would kind of go through the classification within your Revit environment. You have the simple BIM, which provides the easy use of IFC data and workflows. And only recently we've the Naviate Gemini, which is like a handover or archiving solution within the BIM 360 environment. So if, for example, you were a contractor or an architect, and at design intent stage, you have all your files, issues, even check sheets hosted on a BIM 360 or ACC environment, this has the ability to hand them over to someone who might not use an Autodesk cloud hosted environment. They might have their own CDE, but you're meeting your job, you're meeting your requirements at design intent stage to hand over all the relevant approved files in a presentable format. And this is what the Gemini. So it's just one feature within the whole cloud solution. And because we've merged with Microdesk in the UK and US, they have their own built-in cloud solutions as well, like BIMRX, which is like a user management platform where you can add multiple users and control users within the BIM 360 environment. And these are constantly being evolved and developed to suit user requirements at a weekly, if not quarterly, yearly basis. So just go through some of the basic features within the Naviate. So this one here is just, as I said, one of the 100 features. So this is one for room data sheets. So we constantly get kind of feedback from architects in particular that it's an awful manual process in creating room data sheets. So this is sped up to 4 times its speed. So in the traditional manner, what you'd have to do is you'd have to create the floor plan, the 3D view, the elevations, and so on, just to create that particular room data sheet for that room. So here I have to kind of go into the 3D view, slice it, and save it. I also have to just create a sheet and import the views. Now to kind of automate this within Naviate, as you can see, it's a bolt-on that sits on top of Revit. I can select what rooms I want to run my room data sheet analysis, and I just click on create, and there you go. It's after creating a room drawing with my plan and 3D view in seconds, compared to how long it would take within the what would you say, the traditional way. The exact same way is with doors. So if you've been tasked to provide window or door schedules, again, you have to select your particular components and drag them in as legends into the drawing. Again, this is just another feature that has been custom requested by a customer. So you want to pick all door types. You can focus down into filling sheets. And again, what this does is it creates the elevations, plans, and even has a schedule of the door components as well. So, and again, it's all about saving time. And with regards to CQ on time management and the use of the software, these are fully tailored and customized, the configurations of each of these automated processes. So again, it's a time-saving initiative. Next is kind of adding revisions. So if we were to add revisions to a particular drawing or deliverable that you have, it is again another time-consuming aspect where you want to apply revisions to your drawings. Within Revit, you have to do this in individual drawings. I know there are Dynamo scripting available, but within Naviate, you have the ability to do this across all drawings. So I just selected these 3 drawings, and instantly you have the full issue management that's applied to that sheet. And this could be applied to over 100 sheets on a project. And again, it's the mundane task of having to create these sheets. Another feature is the publishing. So again, if you have requirements on a project to provide your DWG export, your Navisworks export on a particular project, this has the way of creating these exports. So what we've done here is we've imported in just parameters that are within the project. This is just a one-time operation where you would kind of set up your ISO 19650 naming convention requirements. It doesn't have to be ISO 19650. What it could be is a particular project driven requirement that you have to have these key naming convention to suit the client's requirements. So this is just kind of to show how easy it is to customize the export and publishing of that DWG format. So what we're doing is just adding in your originator, zone, level, type, role requirements. And also now again, we're just putting in the suffixes to suit the requirements. So I can save these. So what these are is that if anyone else comes onto this project, they have the ability to just publish these to those custom requirements. We could have a deliverable for for ISO and also some other naming standards. So you have two different export types. Again, with IFCs, another requirement, we pick whatever IFC config. You can pick whatever 3D view you want to have exported. And similarly, you can do the exact same with Navis. You can select what 3D view you want. You can have multiple 3D views based on whatever way the project is set. And again, then with PDFs, you can just select your PDF, and through the configuration aspect of it, you just pick whatever driver you have, select what sheets and even sheet sets, which you know yourself, you want to meet certain requirements to match your task information and delivery plan stages. And you can have all these saved into a local network or also up into the Autodesk Construction Cloud. So the Naviate is predominantly a time-saving, non-repetitive process that you just publish your files. This is kind of like an overview of some of the other features. I think the main features are the parameters. So for COBie requirement on projects, you have this parameter values where you can do find and replace within the Revit environment. You don't have to use any export out to Excel. There is the find and replace functionality within the Revit environment. You have the classification. You have the provision for voids, so that if you want to do builders workups, you have the way to approve and reject certain voids on the platform. There is also a way of kind of getting more introduction to this. So if anyone is interested in just kind of getting familiar with these processes, and even this is a free kind of accelerate, it's another Naviate tool to just get awareness of it. There is the option to just use this URL or even use the QR code. It's just rvtbooster.com is the website. And you just get 10 videos just to give you awareness of what the features are within the Naviate brand. So it's just something to people be aware of. And say, moving on from all of this, you've used your AEC collection, you have used your Naviate bolt-ons to streamline the whole project delivery. The next part is to kind of try and push this into an embodied carbon calculator. So Autodesk have the EC3. Autodesk don't have the EC3. It's an integration in with EC3 where you synchronize your model from the BIM 360 environment. What you can do then is you can review and kind of calculate the carbon based on features that you've tailored within this EC3 environment. It also has the large model viewer, which is the Autodesk viewing model platform, where it gives like a heat map as to the embodied carbon data that's within the Revit model itself. What it also does is it highlights elements that have zero carbon data within it, and you can use either a manual process of updating it within the Revit solution, or again that parameter feature within Naviate to update it and again push it back through the EC3. And what that does is as you hand this over to your client or to the contractor at detail, whatever stage of development, you know that you have met your embodied carbon requirements. So thanks everyone for having me. It's just more of a kind of awareness on working in a hybrid solution, utilizing the AEC and Naviate tools. Thank you very much.
That's great. Thanks very much for that. That was really interesting. Sorry, I'll stick my video on there.
Oh.
Thanks very much for that. That was really good, Sean. And I think it shows the opportunity there again with the technology and the digitalization to make all these things practical. Like, so something I found in my previous role was that a lot of the times the concept of having to use BIM or use these other elements on a project and the timelines and everything else wasn't going to make it practical. And that's for that reason there was a lot of kickback. But like, as you say, all those elements of, you know, room data sheets and stuff like that, those creating these extra timelines were made people adverse to using that kind of technology. So those extra add-ons and things like that, where all these things just get automatically produced, I think is a really important development. And I think it's something overall, and again, going back to my old role, I think there needs to be a kind of a collective agreement, I think, between design teams and consultants, that they go to clients and they explain the potential extra time that's going to be required to do these things right. I think it's important that, you know, clients have to be aware that they can't get these much higher levels of quality, production, detail, and all the savings in terms of time and material and costs on site.
Yes.
At the same timelines for the design stage of the project. Like the savings in terms of timelines on site and costs and everything else are so massive on the construction side of things. I think there needs to be a realization from clients, but it's important that the design teams come together so that the architects, I suppose, and look, everyone's guilty of it, but the architects or the structural engineers or anyone else aren't kind of making sure that their bit is right, but then, you know, in the knowledge that possibly the M&E consultants aren't going to have enough time to kind of catch up and do everything. And similarly, that the QSs can't do their jobs as well. So
yes,
I think if there's the whole group comes together and explains to the client through the project managers that, like, this is the amount of time it's going to take, you know, and everyone holds the line on that, because all these things are amazing and it's really important and it is vital, but, you know, it just takes more time to create a better product. So that's my 20-year rant that I've had for a long time. But anyway, yeah, no, it was really positive, Shannon. Thanks a lot for that.
Yeah, no problem. Thanks very much.
So I think we're open to questions now. I'm just going to share the question screen. So that's all the presentations for today. Obviously, there's a lot to think about. I don't know if anyone has any questions on what they've seen.
Just before we start the questions, Amy,
sorry, Alan,
I'm getting a lot of complimentary messages on my phone from people who are at this event. I suppose it just shows that, you know, excellent, succinct messages is ideal for a lunchtime session, you know. So there is a place for remote events, but also for in-person events, which we obviously have tomorrow. But I just want to compliment all the speakers, the quality, the pace of delivery, the coherence of the messaging was really, really profound today. You know, I thought yesterday was good, but like it's even better today, you know, so well done to everyone. I'm going to just ask one question if I can, and that's of Susan, just to clarify. I mean, fantastic project. I don't know what the funding level is, but you're funded by who, and what's the kind of the level of funding for a project of this scale?
Yeah, I don't know the specific details, but it's a Horizon 2020 project. So it's funded by the EU. So it's Positive City Exchange. There's a website if anybody wants to learn more, but it's basically, we have 2 lighthouse cities. One of them is Limerick and one is Trondheim. And then we have 5 follower cities. And the idea is that we're using these cities as kind of pilot sites to develop positive energy blocks. So it's a group of buildings that generate more energy than they consume. So that's why we have the model of Limerick and the detailed models, because that's what we've been looking into. So doing this kind of decarbonisation roadmap is an extra kind of step or application after you have the model. But that's kind of the context. It's an EU project. But for Limerick, we've done a lot of work with the City and County Council and also with UL.
Thank you. Yeah. So, anyone has a question, just feel free to come in, and either with camera on or camera off and ask any questions of our speakers.
I think maybe Susan there, just while people are probably thinking of what they want. I just have a quick question for you, just in terms of, I suppose, going back to what we mentioned there about the benefit of the real life measurement of the buildings. What sort of connectivity is there? Like, are you actually going in and installing certain monitors within buildings, and is it all going back to a central platform where it's, like there's like live data and live graphs and stuff like that showing?
Yeah. So we have in our kind of the 5 buildings that I was showing, which are positive energy block, they all have smart meters installed, or SLUs, smart link units. And they're all connected into our iScan platform. So we have the simulated data in iScan and also the real data. So you can compare and see how close the model is to the real data. So yeah, it's not in every building around the city, but in 5 buildings at the moment they have them.
Yeah, okay. No, that's really interesting, because that's kind of something that's being rolled out in SEAI across a lot of public buildings. So at the moment, there's a reporting register for public buildings where people just go in, all the public sector go into with their buildings and they type in their energy bills for the year. But at the moment, they're rolling out. Again, that smart metering thing that's going to come up, and it'll be a live database. But are you finding, is there major differences between the simulated assumptions that you had and how people are actually using it? Because I think people always surprise you with how
and I think even with COVID, because things were completely different, like we're finding if we want to calibrate a building, do we go back to 2019 data, or do we try and kind of simulate based on how people are using the building now? But yeah, sometimes we'll have people and they'll say, our site survey will say, our heating system is set to 20 degrees and it runs during these times. And then we get there, we see the meter data, and actually people are turning them off or turning them up when they want them. So it is definitely beneficial to have the actual meter data, because I feel like the full use of the building and human behaviors can be difficult to capture in a simulated model.
Yeah, and it's actually something we found with the heat study that SEAI just completed. It's available. It was the largest kind of project that was research project that SEAI have ever done. But it was found that the improvements of insulating a building or improving the heating system and stuff like that, that the actual changes in reduction in usage wasn't what people thought it was going to be, because when people had a really badly performing building, people were essentially sacrificing the energy savings for comfort. So before, when they had a badly performing building or heating system, they only turned on the radiator in the living room when they were in the living room, and then when they went to bed, they turned on the other radiator. Whereas when the house got improved and they got insulation and a new heating system put in, they actually, as opposed to saving 60%, they maybe saved 30% because they let the heating system off now, because they weren't as worried, because they knew they had new windows and new things like that. So I think it is really important. And it's something in SEAI that we're looking to roll out on the non-domestic side. And that's one of my main roles, I suppose, in my new role, is to get real life data so that we can take that human element into account, and then change what we're offering, or change what we're doing to actually achieve what we were hoping in the first place. But yeah, look, this really interesting stuff. I don't know if there's any other questions there from anybody.
A question there, John. Hello.
Yes.
Yeah. So there was talk there at the start of the presentation. Yeah, Jimmy Fahey here.
Hi, Jim.
From GMIT at the Atlantic Technical University now. The whole life carbon industry proposed document Z in the UK. Is there any movement here in Ireland on that document? Is there plans, or can you talk more about that? Any more insight into that?
Yeah, so it's essentially at the moment, and At the moment, it's all going to flow out from the finalised EPBD that's currently, so it's currently in draft, and I think somebody sent a link to it there earlier. So essentially, there is going to be requirements. So at the moment in the draft, one of the things they've noted for embodied carbon is every new building, so from 2027 on, every new building is going to have a full carbon calculation carried out on it. That's everything from the construction, the operational level, and then its end of life if it's being disposed of. So that's going to be a requirement. So once that EPBD is finalised, then the regulations, that'll flow into the regulations. One of the things, and it kind of refers back to the first presentation there, is that's happening currently. At the moment, we're not putting anything together, or we're not finalising anything in Ireland, because it's important that we're aligned with the EU. So at the moment, they're in the train of how different materials are going to be certified, how it's going to be measured, how the materials are going to be certified, and how you're going to be able to register so until that happens, we're not really in a position to kind of put anything together, but we have some draft ideas there at the minute. But once the EU one is finalised, we'll be in a position to get that. So there'll be a required official calculation software and a register then of the different materials and how you need to input those into the software. And that's why you can see like BIM yet again just coming to the fore in terms of its ability to be able to, and again, it feeds into this whole thing that we were talking about there at the last presentation, this idea that I suppose when BIM and everything else came along, that it was seen, certainly I know from an M&E point of view, it was seen as an extra job to have to do, or, you know, a lot more stuff having to be done. But the fact that all these things can be automatically done. So it appears like with BIM, when you're putting in your pipe work or you're putting in all your other stuff, all that, the idea would be all that embodied information in terms of carbon will be all in there. And so when you're doing your BIM calc, and then you end up getting your carbon calculation automatically at the end of it, you know. So so at the moment, that's where things are.
Yeah, there was just a comment there about whether the links provided by some of the delegates could be available. I might ask the team to see whether, when we're sharing, obviously, the presentations and the video, that we could maybe extract those links and give them to the delegates as well, because I know Louis and other people have provided some useful links, as is Ralph, you know. So there's lots of kind of creators of buildings here, lots of designers. I recognize a lot of the names here. Did you find this helpful? Have you any other questions for us? I know we've a comment there from Dan O'Gorman. Is 2027 target date for all buildings being handed over, or stage one? Dan, you might come in there and clarify that question or comment. You can. Dan, can you hear us?
Trying to unmute. Sorry, finding the
okay.
unmute button. So, guys, good afternoon, everybody. Fantastic presentations again today. Just a question on the EPDB. You've mentioned 2027. Is that going to apply from buildings at stage one of the digital plan of work, or is it buildings that are just about to be handed over? Because obviously, buildings that are being designed now will probably, some buildings that are being designed now,
of course,
won't be in construction until 2027.
Yeah, I know. Look, I think like everything, there'll be a ramp up into it, but at the moment, like obviously, it's not even in our regulations at this stage. So I think like there it hasn't been clarified within the EPBD. It's just what it is essentially saying is it just says all, at the moment, the description is all newly constructed buildings from 2027 will need to. So I would very much imagine, don't quote me on this, but I very much imagine that there's going to be it'll be a case that it's, you know, something that's in design stage for the next couple of years isn't going to be fixed to that, because obviously you won't have the ability to have like you don't even have a calculation method at the moment to see what an official one to see what your carbon would be. So I think it's going to be, I'd say it's probably buildings that are probably getting, you know, designed around 2027 from then on. But
okay, that's fine. Thanks for the clarification. Obviously, it makes a huge difference. Second question then is, I mean, is it is it the policy to actually build these targets, which are being set by the EU anyway, as far as 2030 and 2050? Are these targets going to be built in as into the building regulations and into the Irish standards? Because obviously like nothing happens unless there's some reference point. Okay.
Yeah, there's in terms of, I suppose, in terms of the EPBD, I suppose what's going to happen with that is, so if you take the energy, so there's targets for the energy, the minimum energy setting of a building. So like the BER rating, for example. So they're all going to be fixed, and there's going to be minimum requirements for, firstly, public buildings, then new buildings, and then all existing buildings have to be up to that minimum requirement. I think the latest date is 2033. So that's how those elements within the EPBD is going to get fixed in. So like that'll be transposed into Part L, similar to the minimum requirements for renewables in domestic would have been. That's how that got transposed into our requirements in the Part L element.
Yeah, that's fine. Okay, I really appreciate what you're doing, because future generations are dependent on what decisions we make now. For example, Greater London Authority are now insisting on whole life cycle asset assessments for all new buildings over a certain size today. Yeah. So, and I saw all the MPs in Westminster are asking for the London experience to be applied to their cities as well, because their voters a lot are driven by ESG requirements. So it'd be interesting to see how fast Dublin and Ireland follows what's happening.
Yeah. And it's interesting with the news yesterday of Amsterdam announcing their circular economy, approach, and you saw, maybe some of you might have seen the prime time on Monday night. So, that includes, how people shop, eat, travel, and build. And gone is the linear way of doing things, where you design, build, and waste. Everything has to be circular. And so even like circularity brings in, re-entry of, the inefficiencies that we kind of, that we work in construction. Question for me for the delegates, and we might actually grab back some time, because time is precious to us all. But maybe, does modern methods of construction, offsite construction, is that more environmentally favorable? Does that use less carbon? Can anyone answer that question for me? Because I'm struggling kind of to think, while you're still building, okay, you might be building in a factory, but is MMC the answer to this problem?
Volunteer on that one.
Yes, right, John.
Well, we've done our, excuse my cough, it's a bit of a COVID thing going on, but
okay,
suffer me. No, we've done all the carbon calculations. We've done the embodied studies. We've gone through the whole process, not because we have to, but we should. And again, if we're going to stand up and say our system is different, let's say, I'm not going to say better, but different, then we've got to know exactly what the product that goes in, what carbon emissions associated, especially the stages 1, 2, and 3 that was highlighted in the first presentation. That's key to us because we're a supplier. And then we want to look at the in-life use, and we want to look at the end-of-life use as well. So there's a finite amount of resources. We've only realised this quite suddenly through geopolitical issues. The Dutch, as you say, in Holland, in Netherlands, they've been doing this for years. They've captured the whole circular economy thing and run with it, and that's why they're sort of leading in that area. And we've got to say everything's got to go back into the loop. There's no products that should fall outside that. They should be recyclable, reusable, whatever, have an end of life use. This is for the generations after. So yeah, we measured. The thing is to measure and to demonstrate. And then how do you show that? I mean, through Sean was saying he's got the tools to measure and show that we haven't deviated, we haven't substituted, we haven't taken whatever was lying around or maybe omitted. And then you've got a sort of robust record of everything that's gone in. So when you hand it over to a client, they've got they know what they're getting. You know, your iPhone will last 3 or 4 years before it needs to be, sort of replaced or upgraded or whatever. That's a little bit of a dramatic approach, but we need to show that we can do that over 100 years, 60 to 100 years for a building life. If you're an asset manager, and it's asset manager, you need that level of data.
Yeah, very good. Thanks, John. I thought Deborah's presentation was very succinct and to the point, So I enjoyed all the presentations. Unless we have any other questions, we might grab back that time. What do you think, John or Eamon?
Yeah, no, I think so. Yeah, if I'm sure people would prefer to be eating their sandwiches on their own as opposed to in front of us and worry that their mic is on or the camera's on. So I just want to just for my part, Alan, I just want to thank you personally just for inviting me to join this. I'm sure some people were wondering why SEAI appeared at the start. They probably thought they were on the wrong call, but just to reiterate, it is really appreciated to see, and it's really comforting to see as well, even just seeing the CAP 2021 getting stuck up on the screen there, that people are really, I suppose, helping with the heavy lifting on this. And I just want to say from our side, I know SEAI possibly in the past has been seen as maybe domestic, for your solar panels or on your house or domestic retrofit, but we're very much, and especially in 1 year old, very much trying to span all construction and all buildings. So please, anybody, you're more than welcome to reach out. And if you have any ideas, any questions, anything like that, even things we could possibly host on the site of new technologies, please do reach out. So looking forward to more of this.
And we'll be sending the contact details of all the speakers, people, if you need to contact them in the future, if you have any other questions. So that just
there's a question in the chat box from Eugene.
Oh yes, Eugene. So
I'm just going to go through that.
Reuse materials or products in the circular economy. What about fit for purpose or need to meet the product spec?
So in terms of,
or perhaps the product spec will require circularity.
I know, for example, in lighting, for example, CitA have released a document this year, and again, it's the first particular product one that I'm aware of, but CitA released a document in terms of upcycling of and the circular economy of light fittings. So specific to light fittings, because I think we all know with the amount of commercial retrofit that goes on, the amount of LED fittings that end up in skips each time a new client comes along, they strip out, or even a CAD-A office has thousands of LED lights done off their CAD-A, and they're the first thing that disappeared into the skip. So they are looking at, and there's a document there where they're looking at pulling together basically a rating system for different light fittings. So a lighting supplier can get his fitting certified, where there's a system in place when the fitting is no longer required, they take back that fitting and they reuse that fitting, they refurb it and they can reuse it, and they sell it on again. So it still remains as a light fitting, because unfortunately a lot of recycling takes a light fitting and then it maybe technically it gets recycled, but it turns into a plastic cup, or it's always downgraded into something else. So lighting is one of those areas, and CitA have put together a certification method for that. So that's something I think is going to fall out to other products, where it's what happens at the end of this product's life. Do you come back and take it and refurb it and reuse it, or is there elements of it that can be reused, just so a highly technical product doesn't end up disappearing and going down into basic plastic. So I think that will be something products will start having to have, similar to the CE mark. They'll have a circular economy certification on them eventually.
Okay, any more questions? We'll give another second or two, and then I think we may well bring this to a close. So on behalf of the Construction IT Alliance, I'd like to thank Eamon. I think you were the right man to chair this session. Having the expertise, the knowledge and experience in the area, I think you were the right man. So thank you so much for keeping everyone on track. Zulkefly, I really enjoyed that presentation, really technical, but you could see that you're making progress there. Susan, I think you delivered an excellent presentation. Thanks to Deborah. And Sean, thanks for your support. And again, it's great to see these products constantly evolving, constantly improving. You understand your clients, you understand the pinch points and how people use these technologies. So I think what today has demonstrated is that there is a place for remote events. But that brings us to tomorrow. There's also a place for that reconnection and that in-person experience, because it's been over 2.5 years since we've done that. I know you all can't join us tomorrow, but if you can come to the Gibson, you won't be disappointed. Tomorrow is, day one. Yesterday we looked at resource scarcity and increased costs. Today, the change that's needed to think more circular, to think more about designing for low carbon. And tomorrow is about really procurement reform. So just to give you a flavor of who's speaking tomorrow, we have Enterprise Ireland, John Sisk & Son, Siemens, Arup, the BRE Group, BAM, the Build Digital Project, ArcDocs, Future Planet, Modularize, Celebri, Borough Household, and the National Building Control and Market Surveillance Office. So we've got a lot of people speaking tomorrow, all wrapping around and looking at this issue about procurement, because it is procurement, it is contracts that set our behavior, is it not? So again, thank you, delegates, for attending us. I saw a steady increase in the numbers coming in this afternoon, and we do really appreciate you taking the time from your busy schedule. To the people in the backroom team, you don't see them, but to Elenia and Ellen and Suzanne and Sam, super team, love working with you guys. And really, I suppose the big message for CitA, even looking forward, is quality of life for both the people who use our buildings, but also the people who create our built environment. And so this is something we'll certainly be looking at a lot more next year. So thank you again. Good health to you all. And if you can come to the Gibson tomorrow, we'd love to meet you.